Hello, this is Kuntal Chakraborty, Assistant Professor of Electrical Engineering Department, Greater Kolkata College of Engineering and Management, GIS Group. I'm just going to give a lecture on 8051 microcontroller programming. I already discussed 8051 microcontroller programming in my previous 4 lectures. This is my 5th lecture on 8051 microcontroller programming. And in this lecture, I'm just going to discuss the serial communication programming. So before I start the serial communication programming, I'm just going to discuss the important part of serial communication that I already discussed in my previous lecture, and we just want to recall it so that the programming that can be understand very easily. So now the serial port programming, we need every time we need serial port control registers, that is a SCON. So we will discuss the SCON register. So before that, the serial interface that we have to learn, that is for the serial communications purpose, 8051 is used for the full duplex mode. So it's mean the data that can be transmit as well as receive simultaneously. The register SWAP is used to hold the data before transmission and after receiving the data. And this transmission and receiving of data that can be done by using 2 pins, that is TXD and RXD. These are the 2 signals by which the transmission as well as receiving of serial communications that can be done. And next is a serial port control register. This is a register by which the serial communications that can be controlled. And it has a particular address in RAM, that is a 98H. And this is a bit pattern of serial port control register, and here we have some bits which are very important and that we will use for the 8051 microcontroller programming. So here first is a SM0 and SM1. These 2 bits actually specify the modes of the serial port control registers, means serial communication modes. And if it is 00, then that will be equal to 0 mode, and if it is 01, then the mode will be 1. If it is 10, then mode 2, and if it is 11, then mode 3. So 4 modes we have, and that selection that can be done by using SM0 and SM1. Next, REN bit, that is very important, by which we can set and clear software to enable and disable the reception of data. So that can be done by set as well as clear the bit REN. Next 2 pin that is very important, that is T1 and R1. So T1 is a transmit interrupt flag that is set by hardware at the end of the 8th bit time in mode 0 or at the beginning of the stop bit in the other modes, and must be clear by the software also. And next one is the R1, that is received interrupt flag set by the hardware at the end of the 8-bit time in mode 0 or halfway through the stop bit time in the other modes, and must be clear by the software. So T1 and R1, these are the 2 flags, and this is very important for the serial communication purpose. And serial communication modes, we already discussed that mode 0, mode 1, mode 2, mode 3 we have, and I already discussed in my previous lecture on serial communications. And next I'm just going to discuss that is very important, that is the connections to RS-232. So this is basically a standard, and to allow compatibility among the data communication equipment made by the various manufacturers, in interfacing standard called RS-232 was set by the Electronics Industries Association, that is EIA, in 1960. Since this standard was set long before ago, so the logic before the logic family, so its input and output voltage levels are not TTL compatible. In RS-232, a logic 1 is represented by -3 to -25, and it refers to mark, while logic 0 is represented by +3 to +25 volt and referred as space. And for this reason, to connect any RS-232 to a microcontroller system, we must use voltage converters such as MAX 232. So we have to connect one of the converter like MX232 so that the microcontroller that can be connected with the RS232 standards. So the TTL logic level to RS232 voltage levels and vice versa that can convert into the, if you use the MAX232. So now MAX232 IC chips basically are commonly referred as a line driver, and this is basically used to make the communication. And here the two types of connections of RS232 standard, that is DB9 connector and DB25 connector. This is a two connector. This one is a DB9 male connector and this is the DB25 male connector. And here some pins are very important. For DB25 the pin number 2, and for DB9 that is pin number 3. TD, that is the transmit data, pin number 3 of DB25 and pin number 2 of DB9, that is RD, that is the receive data, and pin 4 and pin 7 of DB25 and 9, that is RTS, that is request to send, pin number 5 of DB25 and pin number 8 of DB9, that is CTS, that is clear to send, pin number 6 and pin number 6 of both the connector, that is DSR, that is data set ready, pin number 7 and pin number 5 of DB25 and DB9 pin, that is used as SD, that is a signal ground, pin number 8 of DB25 pin and pin number 1 of DB9 pin, that is a CD, that is a carrier detect, pin number 20 of DB25 and pin number 4 of DB9, that is a data terminal ready, pin number 22 of DB25 and pin number 9 of DB9, that is R1, that is a ring indicator. So these are the pins that is very important for the serial communication purpose, and that is the two connector that is made with the standard of RS232. Now 8051 connections to MAX232, this is the connections we are connecting the DB9 with the 8051 microcontroller by the MX232 driver and line driver. The 8051 has two pins that are used to specifically for transmitting and receiving the data serially, that is the P3.1 TXT and P3.0 RXT, and pin 11 of the 8051 microcontroller, that is P3.1 assigned to TXT, and P10, that is P2.0 is designed as RXT, that I already discussed. And these pins TTL compatible, therefore they require line driver MAX232 to make them RS232 compatible. So MAX232 converts RS232 voltage levels to TTL voltage levels and vice versa. I already discussed how it can be done. One advantage of the MAX232 is that it uses 5+5 volt power source, which is the same as the source voltage of 8051 microcontroller. So at the same time we can use +5 volt with the MAX232. So in this diagram we are seeing that MAX232 driver is connected with the 8051 microcontroller, and we have DB9 that is connected so that the transmission that can be made. So next the programming here by using serial communication, we are just going to discuss the different programming, and by using this program we will try to learn how the serial communication programming that can be done. Write a program for the 8051 to transfer letter B serially at 4800 baud rate, 8-bit data, 1 stop bit continuously. So that is the origin address that is started, and basically we will actually first try to select the timer 1 and mode 2 by writing 20H into the T mod so that it can select the timer 1 and mode 2. Next, we will try to store some data that is basically for the baud rate 4800. So that is 0FAH, that is a hexadecimal number, and that we have to store the TH1. So mode 2 is basically 8-bit auto reload mode. So we have to load 8-bit of count into the TH1. So now 0FAH is our count for the 4800 baud rate. So that data we have to store into the TH1 so that the counter that may be set. Now MOV SCON, #50H. So here the 50H that will be stored into the SCON register. So initialize UART in mode 2, that is a 8-bit and 1 stop bit that that is already told, that 8-bit data and 1 stop bit data. Here we have the mode 2. This is basically 8-bit of data, that is the 1 stop bit and 8-bit of data. So now here we have to write 50 to SCON so that it can be select mode 2 and 8-bit data and 1 stop bit. Next, set B TR1. So to start the timer, we have to set TR1 so that the timer that can start. And again, MOV SBUF, #B. This data we have to send, so that we have to store this data into the SBUF, and then back JNB T1 back. It means it will check whether the content of SBUF that is transmitted or not. When it is transmitted, then T1 that will be set as 1, means this T1 flag that will be set as 1, so that the by setting this T1 means automatically that will be set as 1, so that we can understand that transmission of that data that can be made, that is already made. So now it will continue to check whether the T1 is 0 or 1. When it is 1, then it will clear T1 and it will sjump again, and again the data B that is stored into the SBUF, then it will again send, and by storing 0FAH to TH1, the 4800 baud rate that is maintained. So that is the way we are actually using the SCON registers and serial communication that is made, and that is the one type of serial communication programming. So here we are seeing that how the serial communication that is made. Next, write a program for the 8051 to transfer the message yes serially at 9600 baud rate and 8-bit data 1 stop bit continuously. This is also a serial mode 2 communication, and here the origin address, that is the starting address, and here the start tmod 20H. So we have to select the timer 1 and mode 2, that's why 20H that we have to write into tmod, so that the timer 1 and mode 2 that can be selected. So after that we have to send FDH to TH1. This is because of the 9600 baud rate. So the hexadecimal data that we have to store TH1, so that the timer that can be loaded or counter that can be loaded. So this is a mode 2, means 8-bit auto reload mode. So that's why the data that will be stored into the higher byte of timer 1, that is a TH1. Next, this is actually mode 2 of serial communication, that 8-bit data and 1 stop bit of data. So that's why 50H that we have to store the SCON to select the mode 2. So now setB TR1 means it will start the timer, and then the loop, this basically MOVA, #Y, that data that we have to send to accumulator, and then we will call loop. Here we have a loop where we are getting the data and into the accumulator, and that will be stored into the SBUF, mean the Y that will be stored into the SBUF, and then we have to send the data, and T1 that will check basically whether the transmission is completed or not. If the T1 is set as 1, so it means the transmission is completed, means data stored in SBUF that is already transmitted, and then it will clear the T1, and then it will return to its previous program, where the next instruction is written, that is MOV A comma has E, means E that will be stored into the accumulator, and then again it will call the subroutine ACALL loop and ACALL loop, and here the same thing that is occurred in case of in like Y, and here the data that is stored into A that will be stored into the SBUF, and the transmission that will start, and it will check whether the transmission is completed or not by using the T1 flag, and if transmission completed means T1 flag that will be set as 1, otherwise that will be 0, and the rotation is made in between in this single line, and when it is completed, then T1 that will be set as 1, and then it will clear the T1, and again it will return to its previous program, where the MOV A comma has S written that will be stored into the accumulator, and again it will call the subroutine A that will be stored into the SBUF, and the transmission that will made through this from this SBUF, the data that is stored into the SBUF, and after the completion T1 that will be set as 1, and then it will clear T1, and again it will return, and then we have SJump loop 1, by which the same loop that can be repeat. So that is the way by which this data that can be serially transmit by using 9600 baud rate. So in this lecture I already discussed the program, two program I am actually discussed. First is a program that I discussed, that are data B that is stored that into the SBUF, that we transmitted the data with a baud rate of 4800 baud rate, and here with a 9600 baud rate we are sending the data serially.